Hey everyone, Steve here from ProgrammingMadeEasy.com, and today I've got a video for you that I think is possibly one of the most important videos I've ever done. And this is on how you can use an outside-in test-driven development technique to build an application. And there's a lot to unpack with this video. I'm going to be talking about Outside In TDD. I'm also going to be talking about writing an application that's just a web-based API, web API, RESTful API. So what do you do for stories if you don't have, actual control over the UI or something like that? What if the boundary of the application we're building is just the API part and we don't have full stack access? So that kind of adjusts maybe the way that we think about our user stories and the acceptance criteria. So there's going to be some talk about user stories, acceptance criteria, and how we can kind of streamline this workflow from those user stories and acceptance criteria into a actual development process, some way for us to think about doing the software development that flows very easily and naturally from those user stories and acceptance criteria. And that's what outside-in test-driven development is really helpful for. Now, if you haven't heard the term Outside In TDD, you may have also heard something called the London School. The more traditional way that you do test-driven development, or TDD, is to kind of start with the lower level building blocks of something. Start with some sort of business problem and then just kind of build out from there. So it's considered inside out. The old term is, or the older style is considered inside out or Chicago style, where we're trying to build the thinking part. How would I solve a particular problem? And then we build the apparatus around that. Outside In TDD is a very different way of approaching this. You're still doing test-driven development. You're still writing your tests first, followed by your implementation code afterwards, but you're thinking about things in a slightly different way. And this approach is really, really cool when you start to see how it aligns so easily with user stories and acceptance criteria. So without further ado, I'm going to go ahead and hop into our slide deck here, which the first one, of course, just says using Outside In TDD. And I do want to talk about the objectives. I do want to talk about the objectives of this video in terms of what I kind of want for the outcomes of what you're going to be able to do when you're done. So I do want you, by the end of this video, hopefully you'll be able to explain the practice of Outside In TDD and maybe even how it differs from inside out. You're going to be able to understand or we're going to really kind of outline the differences of the different test types that we try to work with in Outside In TDD. We're still doing unit tests. We're taking integration tests and we're actually doing something different. So instead of an integration test, we're doing some mocking with it, which is another form of unit test. We often call these collaborator tests. So we're going to talk about collaborators. And then there's end-to-end tests, of course. We have Outside In TDD to build web APIs. So you should be able to, by the end of this video, understand how to use the same process and apply it to your own web API building. We're going to develop a cohesive process. We're going to talk about how this process really fits in well together with taking those user stories and turning that user story into production-ready code, because there's this whole pipeline of things that we do from user story to production code, and you'll see how Outside In TDD really makes this happen. So to make this happen, for us to achieve those objectives, this is just kind of how I plan this video to go. We're going to first start off with just some fundamental foundational concepts for those of you who haven't learned these things. This will be a nice little kind of high-level overview. For those of you who have heard these things, you may glean something from this or hear it described a different way, so it may be important for you to hear those foundational concepts in a different way. But we do kind of have to have a lay of the land, right? We got to understand some of these basic concepts first before we start digging into the specifics. Then we're going to take kind of a high-level overview of the different test types, so the different ways that we're going to be building tests, what kind of tests we're writing. Then we're going to set up our environment. We're going to kind of get geared up. We're going to set up our project and get started on putting together something that we can begin to work with. Then we're going to tease out the project requirements. So we're going to kind of take a look at the problem or the thing that we want to provide for our personas, or our clients, our customers, and we're going to kind of figure out what a good set of requirements, project requirements, would look like. We're going to walk through an example of Outside In TDD. So we're going to kind of take those project requirements and actually go through an Outside In TDD process from those requirements to production ready code. And then we're going to refactor, excuse me, we're going to do some refactorings, and I'm going to provide any additional context to what it is that I'm doing. I'm going to try to explain and describe and kind of talk about the theory or the reasons why I'm doing certain things along the way that I do. Some things are conventional, some things are a little unconventional. You'll see I have a different style maybe than what you've worked with before, but we're going to really see how this all kind of fits together. And as we're doing that, we're going to see different things and different decisions that need to be made along the way. Finally, at the end, there's going to be kind of this self-directed activity. I'm going to kind of give you the project that I've been working on, and at some point just kind of stop and say, okay, now the rest is up to you. And that means you have an actual activity you can do after watching this video. You'll be able to take the skills that you've been learning and continue to apply them to some sort of activity. Now, I do want to mention that I think the best way to go about watching this video, I know it's going to be long. I apologize for it being long. Part of the reason it's going to be long is because of all that context that I'm going to provide along the way. And I know a lot of developers really appreciate the context that I provide in these long drafted videos. So I apologize if it seems a little long and repetitious. That's not always the best way to learn something. But I also think that it's important to understand the full complexity of what we're trying to do here. And this is a large, complex problem I'm trying to tackle in this video. But I hope that by the end of watching it, you will have a better understanding of a process that can help you in your day-to-day work. And then watching the video one time, understanding that process is great. And I would encourage you to just kind of do that without your hands on the keyboard, and then watch it again a second time and go ahead and follow along the second time. So kind of hands off the keyboard the first time, watch it again, and put your hands on the keyboard the second time. That's really how I would encourage you to utilize this video. Okay, so without further ado, we're going to talk about the 3 practices of TDD. There are a lot of different ways to go about doing TDD, but these are just kind of some of the foundational concepts or foundational practices or concepts that you should really kind of know about before you begin or try to do TDD. The first one is, of course, just the simple TDD process. Test-driven development is a cycle that we go through. The first thing that we do when we're writing code in a TDD fashion is something that sounds maybe a little counterintuitive the first time you hear it, but the first thing that you actually do is write a test that fails. So you don't write production code, you actually write a failing test before you write any code. So the test is really kind of the specification. We come out of the gates with a specification of how we want the thing to behave or operate or what we want it to be able to do. And then we go into the second phase of TDD, which we call the green phase, and that's just to make the test pass. So we start off with a test that fails on purpose, then we write the production code to make the test pass. And then the third phase of TDD is to refactor our code. So you'll see this cycle happen. Write a test that fails, implement some sort of code that makes the test pass, and then go back and double check your work both in terms of the test and the code, the implementation code, and refactor it to make it easier to understand, or maybe it needs to fit some solid principles, or you think about a design pattern you want to implement. Those sorts of things can kind of start to emerge from the refactoring phase. The trick is, with a lot of developers, is this jump towards the refactor phase very, very early. It needs to be the last thing that you do, and it needs to be very small changes, as opposed to the way most people think about doing development, which is these complex solutions to what are relatively simple problems. So we're going to find with TDD that this gets even more important, that we very narrowly focus our attention to solving the problem that's immediately in front of us so that we can eliminate wasteful effort that might come with a more traditional TDD way of writing, of doing our code. Okay, so that's the red-green refactor cycle of TDD. The next practice I want to talk about is really just, I shouldn't say practice, it's really kind of, it ties into the way that we think about the cycle of TDD, and that are the 3 laws of TDD. It's just kind of like certain gates, if you will, or a way of locking yourself into the process so that you don't allow yourself to get too far out over your skis or do something you shouldn't do. And these are the 3 laws of TDD. The first one is you must write a failing test before you write any production code. So obviously that's describing the red phase of TDD. You can only write a failing test. You can't write production code first. You have to write a test first. The second law is you must not write more of a test than is sufficient to fail. And failing to compile is a failing test. Okay, so you can only write enough of your test. You can only go so far in writing your test as to cause it to break, or to, I shouldn't say break, but to fail. And even if it's failing to compile, that is enough for you to say that it is failing. And you can't go further. You can't continue writing the test. This is a way of basically saying, don't write any more of that test than you need to. Write just enough to get it to the point where it fails, and then stop, and now go into the green phase. Now you can go and actually start to solve the problem. And this includes things like if things don't compile, right? If I tried to compile my code right now because I tried to create a new class or something, or use a class that doesn't exist, well, that's going to fail to compile if I try to do that. So that's enough that you can stop at that point. And then the third law is you must not write more production code than is sufficient to make the currently failing test pass. So that means the solution that you implement needs to be very, very simple. You can't try to implement what you perceive you're going to need 20 steps down the road. You can only do so much, enough of what you need to write in order to make the currently failing test pass. Now, this is going to be a little tricky for you to decide exactly what that means and exactly how much of a refactor are you allowed to do. That's kind of where the your own judgment starts to play a factor into this. How much do I just make the thing start to work versus how much do I implement a bit more of a solution to make this thing work a little bit better? And it's a very delicate balance. You don't want to get yourself into the point where you're actually implementing a full-fledged solution to the whole body of problems or body of tests that you're ultimately going to eventually write. You just want to focus on the here and now. What is the one thing I'm trying to get this application to do? That's really kind of the guiding principle. Okay, so the last one here, and I do probably need to move my, it's a little bit, I'm kind of in the way. Yeah, you can see the green screen behind me. I should be able to turn off. There we go. Hide my camera. So this is zombies, and this is a heuristic for figuring out what the next test is you should be writing. This is a common question that I get when I'm working with developers. How do I know what the next test is I should write? And you can use this zombies heuristic to try to sleuth that out. And it starts off with 0, so think about what the 0 case is. What if there was nothing? What if there was no parameter being passed? Is that something that you want your function to be able to handle? Or maybe your class is handling 0 objects. How would you want your class to manage that? So how would you write a test for the 0 case? Then you would write a test around the 1 case, where if there was one of those things that you were working with. And then there's the many case. So what happens if you have many of the thing? So you write a test around the many instance. And then you have certain boundary behaviors. So these are things like figuring out, and you could kind of lump things like null. What if you had a parameter where you were passing null? That's kind of a boundary of what a null object could, or what a object parameter could be, is that data type might support null. So that's a boundary of the data type. Same thing for min or max. Like what if I'm using an int and I'm using the max int? What if I'm passing that as a parameter value or an argument value to my function? How do I handle that boundary? How do I handle those minimum, maximum, a range, or a certain number of characters I want to allow, that sort of thing? Then there's the interfaces. So you want to think about the interfaces you want to extract from your code. Things like, an actual object-oriented programming interface like we have in Java or C#. Maybe you want to extract one of those interfaces. Also, you can think in terms of interfaces. I sometimes think about them in terms of how I'm writing out the signature of my function. What are the data types I want to use? What are the names of my parameters that I'm accepting? What's the name of my function? What's the name of my class? Those are all kind of considered part of the interface of your application, or the interface of the method you're writing, as you're thinking about the interface. And then finally, there's the exceptions. You're thinking about what the exceptions of this method might be. Is it going to throw an exception? Does it handle an internal exception? What might some of the exceptions be that if it's making something like an I/O call to disk or something and that file doesn't exist, then how would the method handle that type of exception? So you do have to think about those exceptions, and those are more tests that you would want to write. Now, in terms of the S part of zombies, it's simple scenarios, simple solutions. So you want to think about writing simple tests, nothing complex. This is where I really try to stick to one assertion, one exercise, one assertion per test, because I want to keep my tests very simple. The implementation that I provide in my code base should also be very simple so that I'm not coming up with complex solutions to very simple problems. Okay, and that's a very common thing, I think, as we tend to over-engineer what our solutions are. Okay, I'm going to turn my camera back on here, and we'll move on to the next slide. And we're going to talk now a little bit more specifically about Outside In. Those three things, the TDD, rendering refactor cycle, the 3 laws of TDD, and zombies, those are all really just kind of test-driven development concepts. What I want to kind of shift gears into now is talking about the way that we think about writing tests in an outside-in version, in an outside-in format. So the first thing that you need to understand is that instead of writing these low-level unit tests first, we instead want to determine what the overall behavior of the application should be that it exhibits, and that's actually our first test. So instead of thinking about the small low-level thing, it's actually the big user perspective. What should the behavior of this application be? What should I expect it to be able to do? And then you write a test around that. So if we were to just kind of imagine this tree-like structure, this is our code base. That is our tree-like structure. We've got this trunk that's kind of the central trunk of things. We've got all these different branches that go out. And then at the ends of these branches are several different leaves. And it's really helpful to think about this kind of tree-like metaphor in terms of our code, because there's kind of the support of our application. There's kind of the basic support structure, or the framework that maybe we're using that kind of represents the trunk of the tree. And then there's all these different sprouts and ways that the tree starts to branch off, and we call these collaborators. Okay, so there's these branches, the ways that things kind of interact and work together, and kind of manage from the framework, we kind of build out the structure of the tree using these collaborator classes or collaborator functions or modules. And then finally, we get out to these little tiny leaves that are the actual pieces that kind of do the real work, that kind of have the business rules behind them. So just to kind of give this a bit, to utilize this visual for the understanding of Outside In TDD, we first want to start off with this understanding that in order for us to think about our code, our tree as being correct, or being in a good state, or doing the things that we want to do, how do we measure that, right? How do we measure? How can we come up with some sort of way of saying, I know the tree is growing the right way because it does this. I know the functionality we're implementing in our application is good because it does this. And so we think of that in terms of acceptance criteria. Okay, we might also hear of it called scenarios if you're doing behavior-driven development. I'll talk a little bit about what I think is the distinction there between acceptance criteria and scenarios. It's at least the distinction I primarily make in my mind, and I've worked with other colleagues, and this really helps to make sense of something that can be kind of minor. But let's just understand that an acceptance criteria is essentially a way of writing out what it is that the user thinks the application is going to be doing from a functional perspective, right? What can the application do? How tall can the tree grow? How much water is it soaking up every day? How many leaves does it have on it? How many different branches does it have? For every diameter in thickness that the branch is, how many other branches come off of it from there? You could come up with all sorts of different metrics for actually measuring how acceptable that tree growth is. And if you see that, a bush or tree starting to get too far a certain way or certain dimension, or it's soaking up too much water in this area, or this branch is looking dead, you start to prune it, or you change the watering schedule, right? There's different things that you can do. So we're thinking about acceptance criteria in terms of the overall growth of the tree, or the overall growth of the application, the overall functionality of the application. And we codify that acceptance criteria with end-to-end tests. We say this is how our application should function, and we codify that behavior using tests that say, when the user does X, Y, Z, then this should be the output or this should be the result. And we're testing the boundaries of our application, the boundaries of our tree. How big is we kind of test from the root all the way to the leaf, and make sure that everything is in good order and everything measures properly. So with our acceptance criteria, we drop some end-to-end tests. Now, when it comes to the branching off, these branches that come off away from the trunk, we actually call these collaborators. They are the classes in our application that are not dealing with trivial decisions, right? We're not talking about business rules or business logic or branching logic. A collaborator is just simply a class or a module that is figuring out what are the different pieces that are necessary to make this request happen. So what are the different things, the different components and pieces, some business rules that I need to grab, or some objects, some domain objects that I need to grab and work with and organize and orchestrate. That's what a collaborator does. It's not actually intent on the business rules or some sort of decision making. It's really about figuring out, where do I go to figure out what decision to make? Who's going to make the decision? Where should I route this request from the user? That's what a collaborator is. Okay, and really the simplest way of thinking about this is a collaborator has some sort of dependency, right? It says, in order for me to do my job, I have to grab this other thing that is a dependency. So you can think of collaborators as classes that have dependencies in them. Okay. And we mock up those dependencies. So anytime that a collaborator is going to utilize some other service or module or class, it's going to mock that thing so that it doesn't actually use it. It doesn't actually use that real thing. It actually kind of mocks it out instead, saying, I'm going to eventually create that thing. That thing is eventually going to exist, but for now, this collaborator we're going to simply make sure that the behavior of this class is that it does call on that thing. Okay, so it's a behavior-driven development. That's where BDD comes from, is this idea that we're going to make sure that our application is calling and doing the right things, not necessarily state. We're not trying to figure out that 2 + 2 = 4, but rather that, this controller is utilizing this service over here. Now, we often think of that in terms of integration testing. So, utilizing 2 or more services to do some sort of integration testing. But when you're doing outside in TDD, there's really no need for that, because your end-to-end test is the integration test. Okay, the end-to-end test is saying the whole thing must be able to do this, and in order for that to happen, all of those integration pieces must be working. So Collaborator is like an integration test, except it's only focused on one unit. It's still a unit test, actually, but it's really just focusing on the behavior of that class. And we're going to see that happen as we build this thing out. And then finally, we of course have these unit tests, which are these little leaves. And these are the business rules, right? The domain objects, if you will, that are doing the decision trees and such. So the leaf nodes are kind of the smaller pieces, and they don't have any sort of dependency themselves, right? They're actually making the decisions. They don't have something else that they're bringing in to help make the decisions for them. They're actually doing the decision making. So we use unit testing in order to test the capabilities of those leaf nodes. Okay, so this should give you an overall picture of what we're trying to do with Outside In. We're starting with the acceptance criteria, then we're going inwards and thinking about how we're going to branch this application out into the various different parts. And we're writing out our collaborators to say, here's all these different parts that I think are going to be necessary in order to fulfill this request. And then eventually we spread out far enough that we get to the leaf nodes, those little tiny pieces that actually do the decisions, and we use unit testing to actually write out those leaf nodes. Okay, so it's a very complex thing to talk about. There's a lot to lay out there. Hopefully I've explained it well enough that you have the foundational concepts here so that you can, as we go through this process and I explain and go through building an application here, you'll have a good enough foundation of what it is that we're doing and why we're doing those things. Okay, so that's it for my presentation. Let's go ahead and hop into, I've got my terminal window here. And the first thing that I want to do is kind of set up my working environment, my project. And I'm going to start off by thinking about what the user requirements are. And in order for us to do that, I need to explain to you what the project's going to be for. Now, the project that we're going to do is a very simple, everybody by this time should know this little thing. It's called FizzBuzz. I like FizzBuzz as a demo problem because it's very simple, it's very easy to understand, it's very ubiquitous. Most everybody has encountered FizzBuzz. It is a very simple toy problem, and maybe some of you are saying, well, I would like something more real world. I totally get that, but I think that it's helpful to start with a toy problem that is very simple and kind of ubiquitous enough that everybody understands it. So we're going to start off with setting up our environment here that we're going to build our FizzBuzz application with. And we do know that it's going to be a web API, and we do know that we're going to need some tests. So what I'm going to first do is I'm going to define my user stories and my acceptance criteria. So before I can actually build out my thing, I need to have some sort of way of drawing up those user stories. So I'm going to go ahead and create a folder here that I'm going to add a file to that's going to be where we define those user stories and acceptance criteria. So I'm going to change into projects. I'm going to go ahead and just to make things go a little smoother, I'm going to do a .NET new solution file. And I'm going to call this FizzBuzz, FizzBuzz Outside In. Okay, so I'm just doing this in order to create a directory in a solution file. And I'm going to change into that. And I'm going to open it up in Visual Studio Code. There's really nothing in here other than the solution file, but I don't really care about this right now. What I want to do is I want to start off with some definitions of my user story and my acceptance criteria, right? So let's go ahead and create a new file. I'm going to call this user stories. Make it a markdown file. And the first thing that I want to do is come up with some user stories. Now, sometimes what I'll do is I'll go through a what I call a use case workflow diagram. There's a similar thing in Scrum called a storyboard, where we plot out the different stories of what it is that we expect the user story to go through. There's I think something called a feature workflow. So there's a lot of similar concepts that are out there, which is just basically to say, as the user, I want to be able to do this, then this, then this, then this, because ultimately my goal is to do this big long thing, right? And in order for me to do this one big activity, like deposit money into my account or or make a post on my website, or whatever the bigger goal is. There's a sequence of steps that are involved in order to get them from A to B. And so that's kind of the sequence diagramming. And I call that a use case workflow. These are the steps that I expect the user to do. And each one of those steps along the way can be written as a user story. But I think that this is a simple enough example that we don't need to go through a use case diagram. I think we only need what are essentially 2 user stories. So I'm just going to name this user stories. Actually, let's do FizzBuzz user stories. Now, let me talk real briefly about what FizzBuzz is, so that if anybody has never, I don't know, anybody who hasn't heard of FizzBuzz, but at this point, it's probably still a good idea to make sure that you know. FizzBuzz is essentially comes from an old drinking game where you get people in a circle and you're supposed to start with the number 1, and you go around the circle and you name off the number. So 1, 2, 3, 4, 5, 6, 7, 8, etc. And you go around the circle, increasing the number each person that says their number. The next person goes up a number. Now, if it is a multiple of 3, if the number that you are supposed to say is actually a multiple of 3, then instead of saying the number, you say fizz. If the number is a multiple of 5, then instead of saying the number, you say buzz. And if the number is a multiple of both 3 and 5, then instead of saying the number, you say fizzbuzz. So it would be something like 1, 2, fizz, 1, 2, fizz, 4, buzz, fizz, 7, 8, fizz, etc. So I'm probably going to screw that up at some point, but that's the idea. You kind of increase the number in each, multiple of 3, you say fizz, multiples of 5, you say buzz. If it's a multiple of both, you say fizzbuzz. Okay. Now, the purpose of this application will be to provide an API for anyone to use, where if they're building some sort of front-end UI, they can use our API to figure out what should be said when a number is passed to it. So they're going to give us a number. Our API is going to receive a request with a number on it, and then we in turn give them the answer, whether it should be a number, fizz, buzz, or fizzbuzz. Okay, so that's the ultimate goal of this exercise. So what are some user stories? Well, before I can define a user story, I have to define my user. Who's my persona? Who are the people that are going to be utilizing this? And this can sometimes get a little tricky, because quite often you will hear that a user story or persona for a user story should be the user. And that is correct. It's the user, the consumer, the person who is going to utilize your application boundary, which is not the gamer, the perceived gamer, the conceived user that is using this developer's user interface. Instead, our persona is the developer. That is who. Now, it's not me. Not when I say the developer, I don't mean me, the developer of the API. I mean the developer that is creating the user interface. And that provides me a certain level of flexibility because of the context in which I know that my user is, right? I know that my user is capable of understanding certain terminology. So when I write my user story, I can have a little bit more technical jargon that matches the reason why they want the thing. So instead of a user story being about specifically the user of the UI, instead, the user of my API is another developer on some other theoretical team. Maybe it's another company, right? So that does mean that my persona is a little bit different. And I'm going to go with a developer named Developer Dave. Okay? So that's my persona. And that's just kind of an important thing to know. Who is your persona? These are sometimes called intermediate personas. Some sort of developer on another team that is going to be utilizing the application that I'm building. But since my application boundary stops at the API and I'm not building the UI, then the persona is the developer who's writing that other piece. Okay. So Developer Dave is going to be our persona. And let's just think, in terms of what I want this to do, it's actually fairly simple. I only have 2 stories that I think need to be done. And in fact, it could have been done as, this user story could be done as 1, but I'm going to go ahead and separate it out into 2, and you'll see why as we move along. So as developer Dave, I want so that. That's kind of the format that we're going to follow. Okay, I love this template. As so-and-so, I want to XYZ so that I can so that I can 1, 2, 3. Okay. So what is the action that developer Dave wants to be able to do? Well, I want to, as developer Dave, I want to submit a number to the API so that I can program my application to perform an AJAX request at the endpoint. Okay. Now, this is where I'm saying there's some flexibility here. That is not the right way to spell application. There's a little bit of flexibility here. You'll notice that I am saying AJAX, and typically when I say, when I'm thinking about writing user stories, I try to avoid any sort of technical jargon or some sort of implementation detail. But the reality is that is something that my user is actually very comfortable with. They know what AJAX means. They know what endpoint is. And in fact, it goes directly at the heart of what they want to be able to do. So it's not necessarily that I'm talking about an implementation detail for myself, but rather so that I know the context in which this user wants to be able to use this thing. Okay. The next user story that I'm going to have is something that says, as developer Dave, I want so that, okay, I want, what does developer Dave want? So we already have the ability to submit. So developer Dave wants to submit, but also after the submission process happens, developer Dave wants a response back, right? So I'm going to say I want to receive, there we go, EIV, a FizzBuzz answer in the body of the response so that, oops, so that goes down here, so that I can program my application to display the response to my user. Okay, so now you may be thinking, I have a better user story. You may very well be able to come up with better user stories than this. These are just 2 that I came up with. And essentially one is the inputs and one is the output. I could have written this as one user story that was both the input and the output. But I think sometimes it's really helpful to think about this in kind of these 2 different terms. Okay, the user wants to be able to do this, and then also as a response, the user wants this to come back after that particular action has occurred. But again, I could have written this up as one user story instead of 2. I just thought for the purposes of this exercise, you're going to see that this is kind of helpful to do. So now what we need to do, now that we have some user stories, we need to come up with some acceptance criteria. And this is really the first stage of thinking about it from an outside-in perspective, from doing Outside In TDD, is we've got to think about what would we say if developer Dave is going to submit something, what are the acceptance criteria? How would we measure that? How would we know that Dave is able to do this, to be able to submit this information? So we're going to write out some acceptance criteria. And the first one is, and I use the Gherkin format, and you'll see why this is so helpful to do. Gherkin is the language that this language syntax I prefer, which is where we use given, when, and then to describe essentially the 3 different phases or the 3 different criteria of a test, which is given this set of circumstances, when this action occurs, then this should be the result. Okay. And that's essentially the same things, the same 3 criteria that we have for when we're writing a test. That's arrange, act, assert, right? So given, when, then, arrange, act, assert, they are the same things. They're just two different ways of saying and articulating the exact same sequence of events. So I'm going to say given so what's the given here? What's the thing that that we would say are the set of circumstances that need to be set up first? So before we can exercise this ability for developer Dave to submit something, what must be happening first? Well, the service needs to be running. So that's what I'm going to say. Then given the service is running, then the next part of Gherkin is to say when. So we're going to say when. So given the service is running, and then the when thing is what is the actual specific action that developer Dave is going to be actually taking. And for me, that would be when a GET request is submitted to API fizz buzz, and this is where I can dig into some of the specifics. I can say, this is the route that I should be able to go to, and is there going to be any parameters? Now, so I'm again trying to think about what is the test I want to write. And remember, we talked about zombies as the heuristic for figuring out what the test is that you want to write. So in terms of my acceptance criteria, I'm thinking of zombies. And the zero case of this given when then, or the zero case of acceptance criteria for developer Dave submitting a number to the API is, well, what if he doesn't give me anything? What if there's no parameter? That's my zero case. So if when a GET request is submitted to API fizzbuzz with no parameter, that's my zero case. Then what should the result of that action be? So I'm not thinking green here. I'm not thinking the happy path. Okay, I'm thinking of the zero case in my zombies. So the result of that, I think, should probably be a 404. That's how I think my application should respond if developer Dave doesn't give me any parameters. So I'm going to say then the response should return a status code 404. I'm going to do one more here, again using zombies. What's the one case? What happens if developer Dave gives me one of these things? So given the service is running, same setup, right? When a GET request is submitted to API fizzbuzz with, I'm going to go ahead and go green path here, or the happy path, with a positive number parameter. Then the response should return a status code 200. Okay, so I'm not getting into the solution here in terms of if developer Dave gives me a 3 or a 5 or a 18 or a 15, right? I'm not getting into those specifics. I'm getting into the general behavior of what is acceptable, what type of information could developer Dave give me, okay? I'm not even talking about the response yet. And in fact, it makes more sense for me to talk in terms of the response or what the solution is. It makes more sense to happen in the second user story because that's where developer Dave is going to be expecting those answers. But for right now, developer Dave just wants to be able to submit something to me, and I need to be able to accept it or maybe reject it, depending upon what kind of information might I be rejecting by. So that's where I'm going to say my zero, my one case, and then the many case. I'm going to go ahead and copy what I have here for the other ones just to kind of shorten up. This video is already long, so I kind of want to shorten things up a little bit. So these are going to be my other given when thens. And these are all my acceptance criteria based around, and I'm using zombies to kind of figure out what developer Dave is going to be able to send to me. Then I can start to work on the response that I give back. And the first one is, once again, we're going to think about the zero case. So once again, given the service is running, when a GET request is submitted to API fizzbuzz with no parameter, then, okay, so this is the same scenario essentially here, or the same acceptance criteria up here, except now we're talking about what goes in the body of the response, okay? So that's the slight difference that I have between my user stories, is that this one is about his submission to the API. This is about the response that comes back from the API. And you don't have to do it this way. I could have put all of these acceptance criteria together as under one story, but this is just the way that my brain decided to segment these two stories out and break them up, and then also help me think about the acceptance criteria for each one of them. So in this particular case, what do I want in the body of the response if Dave has given me no number, right? There's nothing at all. Well, then that means that the response body should contain an error message indicating a parameter is required. Okay, so that's essentially what I want to happen in the body of my response if Dave gives me no number. Okay, we're going to do the same thing for the one case. So once again, given the service is running, so this is my, once again, zombies, 0, 1, many. So my one case for this is probably actually the happy path, right? When a GET request is submitted to API fizzbuzz with, okay, with what? Now we can talk about more specifics, because we know that there's some branching logic here of what we expect. If the number is a 0, 1, 2, 3, 4, 5, 6, 7, there's going to be all sorts of different situations, certain scenarios under which we expect different outcomes in the body of the response. And to me, that is the difference between acceptance criteria and scenario. So you will sometimes hear of these terms used interchangeably, but to me, there is a distinction in that acceptance criteria is a bit more generic and not specific in terms of the data and state and decision making or logic branching based upon some sort of data. That's what a scenario is. A scenario makes those decisions based upon specific data. Whereas an acceptance criteria is just kind of much more generic, like this is what they should be able to do in a more generic sense. So I'm going to start to write out the scenario here that instead of no parameter, we're going to say with a positive number parameter that is a multiple. I spelled parameter wrong. That is a multiple of both. I'm going to start off with the case of both a 3 and a 5. Then the response body should return fizzbuzz. Or I should say the response should return fizzbuzz in the body of the response. Okay, so that's going to be, so this is a scenario. This is just taking the one example, very similar to how we had a positive number up here under this user story. It's a positive number, but we're being much more specific about what kind of number. And that is the difference to me between a scenario and acceptance criteria. You may not want to make that distinction. Maybe this is a distinction without a difference to you. That's perfectly fine. I am fine with that. Now, to kind of speed things up here, I'm going to take the rest of the other scenarios and acceptance criteria that I've written, and I'm just going to kind of post them all up here. And I will make this available to you on a repository and I'll make it a link here in the description of this video so that you can get all of these yourselves, because at some point, what I'm going to do is I'm going to release you to start trying to complete all of the other stories that I have here, or all of the other acceptance criteria and scenarios that I have here. But this is essentially my planning process. Okay, I've taken what is essentially the user requirements, I've broken them down into user stories, and then I've taken each one of those user stories and I've determined the acceptance criteria and or scenarios that fit those user stories. And the idea with outside-in test-driven development is each one of these acceptance criteria and scenarios will be an actual in-code definition. And when I have all of these acceptance criteria passing, then I know that my story is done. So that is an important key to all of this. I didn't just decide to do this planning for nothing. I wanted to show you this process on purpose. It is the beginning of Outside-In TDD. It's the starting point. User stories to acceptance criteria and scenarios that we are then going to convert into actual code. Okay? So, now that I have my user stories and my acceptance criteria all written up, and I used zombies to figure out what each one of these was, and these are all from the perspective of the user and, you know, the acceptance criteria that is going to help us define whether or not that story is done. So now it's time for me to actually start building out my project. So what I'm going to go ahead and do is I'm going to make my xUnit project. So I'm going to do .NET new xUnit. And I'm going to go ahead and call this FizzBuzz tests. Yeah, I think that should be fine. And then once that's done, I need to add it to my solution. So I'm going to do .NET SLN add FizzBuzz tests / FizzBuzz.tests.csproj. And that just simply adds the test project to the solution file, which is this solution file that we created initially when I first started. And you can see there my test project has been added. I'm also going to add, I'm going to close my user stories for now. I'm also going to add to this, because I know that there's some libraries that I want to use in my xUnit project. And that's going to be my test host, which is, we'll see how test host works later on, but also Fluent Assertions and MOQ, which is my mocking framework. So I need to add some packages here. I'm going to say, let's change into the FizzBuzz test directory. And let's go ahead and add .NET add package Microsoft.ASP net core test host. We'll talk about what that package is for a little bit later on. .NET add package Fluent Assertions, which is a really handy library for writing assertions in your tests. Makes things a lot easier to read, and you'll see it helps. Given our given when then Gherkin syntax, you'll see how it just works really nicely with that. And then finally, I want to add MOQ, so I'm going to do .NET add package MOQ, and that is our mocking framework, right? That's our mocking library to mock out certain things when we're writing out our collaborator tests. Okay, so I've got my test project here. And it's really not doing anything. I can do, let's change directories up here. Do .NET test. And you'll see that it's just going to pass as green because right now our test isn't really doing anything. Okay. Now, what I want to do is I want to write a failing test. Notice that I don't even have a project yet. I don't have a web API project. You write your tests first, and the first thing you want is a failing test. And so the first test that I'm going to write is actually going to be about spinning up an instance of the server. How do I know that that's what my test is going to be? Well, I already told myself that that's what it's going to be because I wrote out my user story acceptance criteria. So the first test I want to write, I don't have any production code. I don't have any implementation here. Instead, I start with an end-to-end test. We're doing Outside In TDD, test-driven development. The first thing we write is a test, and the first test we write is an end-to-end test that describes how the system should run. So I'm going to copy that acceptance criteria that is the first thing that I have, and I'm going to go to my test class, and I'm just simply going to paste it here. I'm going to just paste my given, when, then, but I am going to break it down between the given, the when, and the then, so that those are on 3 separate lines, and I'm just going to kind of break them out here. Now, earlier in this video, I said that given, when, then is another way of saying arrange, act, assert. They are the same things. And we're gonna see that here. What is the setup? What is the arrangement? What is the given? Well, I've got to get the service running. So what I'm going to do is I need to create an instance of the server and run it. And that is where the test server, this hosting package that I brought in. There's fluent assertions. This one here, this test host package, Microsoft.ASP.NET Core.test host. That is the package that I'm going to use, the library that I'm going to use in order to spin up a test host. Okay, a host, an instance of my host that I don't even have yet. But that's fine. We'll see how that works. We're going to see that that's going to be just perfectly fine. So in order for me to do this, I need to define a test server. And it's not giving me the red squiggly line because what I need to do, because of Omnisharp, is I need to select the project. Yes, there we go. Okay, so now test server should be failing me here at some point. Yes, build them. Build them. There we go. Now that red squiggly, there we go. So now I've got my IntelliSense. Okay, so I need to bring in the using statement for test host. But in order for test server to work, I need to pass it a web host builder. I need to pass it some sort of host builder. So I need to define a host builder. And then we're going to pass that into our test server. And you'll see that I just need to bring in Microsoft.ASP.NET Core hosting in order for that web host builder to get created. But now I need to create it. And this is where things get a little bit tricky because I don't have a project yet to build. So I'm going to add some code here that's going to fail to compile because the project that I want to use doesn't exist. But I can start making decisions and thinking about things, okay? So the first thing is I'm going to use a content route because when I'm coming up with the web host builder, when we're doing web APIs, you have to say that the root of the application, you have to point to where the root of the application is because, especially with web APIs and MVC applications, they are using some, they're using application context to figure out where the controllers are, right? The folder structure of the application is helpful in figuring out where the controllers exist, where it should direct routes to. So I actually have to tell my web host builder here in my tests, don't use my local test directory. I want you to use the directory where the project exists that's going to be my web API. But that doesn't exist yet, so we're going to have some problems, but we're going to use our test-driven development process to figure out what those things are. I'm going to use the path. Path is from system.io to get the directory name of the assembly, which uses reflection, for the type of startup class. So with any sort of web API application, I have a startup class, right? With a ASP.NET Core, MVC, or web API application, I have typically a startup class that is describing my configuration settings. So I'm going to use that because I know that should exist in the root of the application wherever I put it. And then I'm going to use the location of that assembly to pass into the path of get directory name for my use content root. Okay. And that's going to essentially be the location of where I'm telling this test project to go find my API project. Okay. Now the problem is startup doesn't exist, right? I'm getting a red squiggly line here. So I can't really proceed any further than that until I fix this, right? Because we're not allowed to write any more of a test than is sufficient to fail. So I need to go create that. Well, I don't want to generate my startup class like this. Instead, I need to go create my project. So I'm just going to go ahead and change directory. Well, I don't even need to change directories. I'm already in my root of FizzBuzz Outside In. I'm going to go ahead and do .NET new web API. My output is going to be FizzBuzz web API. That's the directory I want to create it. So that's going to make this new web API folder with my new project in it. And there's my startup file. Now I just need to simply fix my test so that this startup class that I'm pointing to, since it has a missing reference, now I just need to simply make it so that this test project knows how to find that startup file or that startup class. So in order for that to happen, I need to do a couple of things. First, I want to add this new project I just created of web API. I need to add it to the solution file because right now it doesn't exist in there. It still only has just my tests project. So let's go ahead and add that. We're going to do .NET SLN. Let's see, what was the command? It was SLN add, and I need to go to fizzbuzz.webapi /fizzbuzz webapi.csproj. That's the first thing I need to do. Then the next thing I need to do is I need to go to my test project, this csproj, and add a reference to the FizzBuzz web API. So I'm going to do, let's go ahead and change, oh no, I can do .NET add to my fizzbuzz.tests or /fizzbuzz.tests.csproj file. I want to add a reference for that test csproj file of the ./fizzbuzz.web API fizzbuzz.web API.csproj. Okay, now my test project has a reference to the web API project. And that way my test project can go find this startup file finally. And now I should have it. There we go. We can see there's my using FizzBuzz web API. So I'm using the test to help me kind of figure out how to build my application. Before I even have a project, my test is the first thing that actually says I even need a project. Okay, I have a requirement first before I go create the thing. And you're going to see that's happening throughout the rest of this entire process. The last thing that I also need to do is to add the startup as the use startup. And that is just one of the methods that we call in order to tell the host builder which startup class to use for the configuration stuff. So we used this path get assembly of the location. That was just simply to say, here's the content root, but then we also need to pass in the startup file for the configuration stuff. And you'll see that that's the same thing that we see inside of the program.cs file, is a similar thing where we're saying on the web builder, use this startup file of the startup file, right? The startup class. Okay, so I've got that. The last thing I need to do in terms of my given and my setup here is to go get a client that's going to actually make the API call. And since we're using test server to do this, we can actually just define a client here from that test server. And actually we need to use the, create client. There we go. Okay, so we're going to create our client right there. Okay, so that is our given. That's our setup stuff. Setting up the server. In order for us to, given the service is running, in order for us to get a service that is running, I need to do all of that stuff. And in fact, if I do a .NET test, we should see that we're passing and that we're green. Okay, I haven't written enough of this test yet again to fail. So what's the next thing? Well, I need to make it so that we're calling that API, right? We're calling this API FizzBuzz. So we're going to use the client. And we're going to do a get. We need to do get async. So when we're using async, that means we need to do an await statement here. And we can then pass in the API FizzBuzz as the route that we want to go to. Now, it's going to complain about that. Let's go ahead and fix that because we need to make the method async, which means that it's returning a task. And to further fix this, I'm just going to do that and then bring in the using statement because I hate using full namespaces. Okay, so that is going to do our get of the FizzBuzz. Now, the last thing we need to do is make sure that our then statement, our assertion, is good. So we're going to take the result and we're going to check the status code to make sure it's 404. To do that, I'm going to use the fluent assertions. And say that the status code should be 404. So you can see, then the response should return status code 404. Result.status code should be 404. It kind of matches. Notice that the flow of our test for our end-to-end test matches exactly what we have in our given, when, and then statements, right? Given when a GET request is submitted to Web API, to API FizzBuzz with no parameter, right? There is our submission, the GET request to API FizzBuzz with 0 parameters. Then the response should be status 404. So there we can see our assertion is making sure that it is 404. Now, the thing about this particular test is that it's still going to pass. We actually haven't written a failing test at this point anymore because that's actually the default behavior of a web API. If I wanted to see what this looked like, I could go here and just change this to 200 so you can see what a failing test would look like. But it should be 404, but if I said that it was supposed to be 200, you can see it's failing. Status code to be 200, but found, not found. Okay? So let's change this to 404. We're back to a passing test. And now, since we're passing our test, that means we're in the refactor phase. And the refactor phase is where I like to go through and do something you may have caught that I didn't do early on, which is I didn't name my test. My test has so far just been test1 async. And also the name of my test class is just unit test1. This is something that I do regularly. I wait until my refactor phase to decide what I want to name things. So what I'm going to do is I'm going to want to make this class, this unit test class, about the calls that are being made, the end-to-end tests that are for the calls being made to the FizzBuzz route, more specifically the GET requests being made to that route. So I'm going to go ahead and call this FizzBuzz GET route. That's the name of my class, and so with that, I'm going to go ahead and copy that And I'm going to rename my file as well so that it stays consistent here. And then I'm also going to change the name of my test from test1 async to something a little bit more helpful. So the naming convention I like to follow is to say what the test is essentially doing, right? It should be, or like when I call this route, then it should return this when there's no parameters. So essentially a brief synopsis of what it is that the given when then statement is saying. So it'd be something like this. Should return. So this is the get route, right? We're specifically talking about this get route. From the API user consumer perspective, the developer that is writing the user interface, they're making a get request to the FizzBuzz route, and I'm saying that it should return a 404, right? Return, let's say, status code 404 when no parameter is passed. Now, I am also going to make this async because this is an asynchronous method. Remember, we have the await happen in here, and it's typically good form to add the async keyword to any method that is asynchronous. We can see we're using async there too. So just something that you should know is you should be adding that async to any tests that are asynchronous. That's one refactor. What about, is there anything I need to do in my project? Yeah, I have this weather forecast controller. Let's nix that. Same with the weather forecast class. I don't need any of those things. And that refactoring, I'm just doing my refactoring phase. I think I'm done with my refactoring. Run my tests again. Make sure that my refactors didn't break anything, and sure enough, everything passes. So now I've properly named my tests. I've got a proper project created. I've removed all the unnecessary things that it doesn't need. Everything has been refactored. We're good to go. We're ready to move on to the next test. So what is the next test? There's my user stories. Here's my next acceptance criteria. Let's just go ahead and copy that. Go back to my FizzBuzz get route. Make a new test here. And in my inside of the test, I'm just going to paste that same exact acceptance criteria I wrote before. This is, again, the beauty of doing outside in TDD is if I've got those acceptance criteria written up, they serve as the foundation for the test that is going to be the first test I write, so that I know what the next test is I need. Okay, so this next one is given the service is running, when a GET request is submitted to FizzBuzz API with a positive number parameter, then the response should return a status code 200. So rather than write all that back out, I'm just going to copy it because that's how we know our service is up and running. So I can just go ahead and do that, copy and paste. We'll get to refactoring that in just a moment, but for now, I'm just going to copy and paste to get the service up and running. Then the when statement is going to be a similar thing, right? Var result comes from await of client get async, and this time we're going to pass in a positive number parameter, and it doesn't really even matter, right? Because the purpose of it doesn't even matter what that number is, right? It just needs to be a positive number parameter. The thing that we're looking for and the thing that we're going to assert on is that it should return a status code 200, not what the FizzBuzz or number or FizzBuzz, not what the response is in terms of the answer, but rather just that my host is accepting the request. Okay, that's all that I'm essentially doing here. So once again, make it async, and then the result status code dot should be 200. All right, so let's go ahead and run that test. And we will find a failing test. Okay. So our test is failing. What is something, now we just need to do something to turn it to green. And the thing is, when we're doing the conversion to green, what we need to remember is to do the simplest possible thing. And the simplest possible thing in order to make this work is to just simply add a controller to our project called FizzBuzz. And it does need to come from controller base. Now, I'm doing Outside In TDD. Some of you may be thinking, wait a minute, this is a lot more production code than I think that I should be making, or these are some of the decisions, more decisions than I should be making. That's not entirely the case, because all I'm trying to do is whatever the minimum amount that is required in order to make this test pass. And in order for this test to pass, the thing that you have to remember is I am spinning up a full instance of the web host, which means I have the full app context going through and finding the controllers to find the route and everything to make this work. I'm trying to make this test pass for a route, not that the class responds or has a method on it that responds with a given result or output based upon parameters. No. I am actually needing to do the bare minimum within my architecture to make it so that this thing passes. Abiding to the rules of the architecture, abiding to the rules of the framework that I'm using. I have to do all of that in order to make this work, which means I have to have a controller base. I have to make this say that it's an API controller. And then I have to go down here, or actually I need to add a route now too, right? I have to go here and say route API FizzBuzz, right? It's going to be the controller for my FizzBuzz. And I need to make HTTP GET. And more specifically, it's going to receive a parameter, right? I've got to have it accept a parameter. I'm just going to call this number for now. I'm going to have it return an iAction result. And it needs to take in that number. Like, these are all minimal things I have to do to finally get to the point where we're returning OK. Right? Like, that's just the minimum. I can't do anything other than that. I might have been able to make it so that the HTTP GET had the route in it. That might be something I could have done that was a little bit less. But, like, this is just the simplest possible thing I can possibly do to make it so that this test finally passes. Okay? And now that I've written this FizzBuzz controller that returns OK, I probably I could go and create another test, which I actually probably should have done. So let's just roll this back for a moment. I'm going to actually delete my FizzBuzz controller. That was the minimum possible thing I could do. But since I created something new, before I can go and create that class, I actually need to decide, is this going to be a collaborator? Is this going to be a leaf node? Is this going to be a wrapper? What kind of thing is this going to be? Is it just the business logic, or is it going to be a collaborator? So because of that, I'm going to say for now, I know ultimately it probably will be a collaborator, but I'm going to start off with it. It just needs to solve this one simple little problem, and that is it needs to return a 200. So what I'm going to do is I'm going to go back to my FizzBuzz tests here, and I'm going to add, I'm going to actually start to kind of organize this thing because it's a little bit goofy. I'm going to add a folder here. I'm going to call this Fizz, well, not yet. We'll backtrack. We'll do that during the refactor phase. Sorry, I'm jumping a little ahead here. Let's go ahead and add a new class file in here. I'm going to call this foo. Well, I think I know at this point that I'm probably going to go ahead and call it FizzBuzz controller. And Nah, you know what? I'm going to be even more ignorant than that. I'm just going to call this foo for now. I know, I'm really stretching the, oh, come on, Steve, you already know some of this stuff, but not just yet. I'm not fully confident yet in my name. And you'll see why here in just a bit. So I'm just going to write this class as foo. This is going to be a test class. So I need my first fact. I don't have a given when then, and this is where things change a little bit. We have to change gears a little bit with Outside In TDD. Our first test that we wrote was for the route, that is our end-to-end test. But we have a failing end-to-end test at this point, right? It is not passing. Because our FizzBuzz get route test is not passing, my end-to-end test is still in play. I still haven't solved it yet. So now I have to think about, okay, what are the pieces that I need to build to make it pass? No longer is it just enough for me to build a project, a web API project, and add the references and stuff. No. I really have to go through and actually build something now. I have to come up with a controller and an endpoint and blah, blah, blah. We already know that. But before I can go create those things to solve this end-to-end test, I need another test that actually is what I use to scaffold up what's actually built. And for that, I'm going to go ahead and drop this given when then because it's not the same thing. We're kind of going back into just the simple basics of, I don't even know what it is. We're kind of going into the low level, kind of the inside out approach now. What am I going to build? What does need to be created? So now I'm going to use this as a whiteboard scenario where I'm going to think about those things. I'm going to start to make those decisions. What is it that I actually want to build now? And for me, I'm going to go ahead and call this var SUT, system under test. And I'm going to say it's a new FizzBuzz controller. Okay. Now, I need a FizzBuzz controller. How do I do that? Well, because right now this is failing. This is going to fail to compile, right? If I do .NET test, this is going to fail to compile, right? Could not be found FizzBuzz controller. So I have to go create that thing. I could go and create it in a new file right here, and that's fine for now, but I already know it's going to need to go somewhere else, so I'm actually going to delete that. Some folks like to do that, is to build it in the test project and then move it later. But I don't see any particular reason for doing that. I think we can just go ahead and go create it now in controllers. Makes sense to make it there, but I'm not going to add any of the other things to it. I'm just going to do enough, the bare minimum that's required in order to make this compile. Oops, did I? Oopsie. How did I? There we go. I deleted the wrong file. That was why. Okay. So now we should be able to pass, at least compiling, right? We're still back to our end-to-end test is failing, right? There's our test name, async is failing. Status code to be 200, but found not found. So we just only have the one test that is still failing, our end-to-end test, but now we're passing this one. But I'm not done writing this test yet. I'm not done creating my controller. What do I need this controller to be able to do? Well, I need it to, I know that I'm going to want to have it return something that's going to make this return okay at this route. So I need to add a method on here that's going to return some sort of iAction result of status code 200. So I need, on my system under test, I need to call on it, let's call it the get method. And I need to be able to pass it a number, which we know is going to be like a 1. And that should return an okay, right? It needs to be an iAction result type. So I'm just thinking about, I'm kind of using this test to figure out, okay, what do I want the method name to be on my controller? I think I'm just going to call it get. It should take in a parameter and return an iAction result. I can go ahead and generate that method on my system under control, or system under test. Okay, so now that passes. Now I just need to make sure that the result, I actually want to make sure it's an okay result. I think that should be fine. Or I could have done this maybe a little differently here. I could still do iAction result as the result type. We could say result should and we should be able to say be of type, and we can say and it needs to be of okay object result. And just to make sure, oops, wrong test. Just take a look at it. You can see this is what the implementation is, that it's decided now, right? iAction result is the data type that's the output, takes in some sort of parameter, throws new not implemented exception. This should fail, right? It should be a failing test at this point. So we should see that the fails goes up to 2, and we can see failed 2. We can see each one of them. The first one is the method or operation is not implemented. And that's simply because it says it's throwing it here. So let's go ahead and return okay. Now that we have a result. Oh. Should just be able to do return okay. Oh, we can't actually right now because this is, I know exactly why, because this is not currently using the base controller. So it needs some sort of object. It's not going to like that. So we need to do okay result. And that way it should work fine. And that means our okay result, it's not going to be an okay object result. It's actually just an okay result. There we go. Okay, so now that we have that, let's see if this works. We should hopefully, fingers crossed, have 2 passing now. Yep, we do. We can see it is now passing 2 of our tests, but we're back to the original problem here which is status code 200, but found not found. The problem that we have at this stage is no longer that the controller is not built, but rather that the routing of this test back here for our get route, this routing is still not applying. So I've still got to go and fix that on this test. I've got to say it's an API controller and it's got the route. Let's go ahead and make this actually HTTP GET, and it's going to get from API FizzBuzz number okay. Now let's see what happens. Okay, now we're passing. So we have our foo test class, which I haven't named anything yet because I'm now going into the refactor phase, but I've got my FizzBuzz get route, this test that's passing, and my foo class and its test is now passing. Everything is green, so now I can go in and refactor. This starts with all the names. All the names need to be fixed. This shouldn't be a test class called foo. Now that I know what this is testing, it's going to be the FizzBuzz controller get method. And I'm talking about specifically this get method. Now the name of my test itself is should return OK result when passed positive 1. Okay. I've got my class name, so I can go ahead and rename the file. And now in order to keep things organized, I'm actually going to kind of folder structure out my test project here. So I'm going to add a new folder here called FizzBuzz. Actually, we'll do, yeah, so this will be FizzBuzz controller tests. And we can move that into the FizzBuzz controller tests. I could move my end-to-end tests into a separate folder. Sometimes I'll do that, is to make another folder in my test called end-to-end tests and move those in there, just to kind of keep things organized. So we'll go ahead and do E to E and move that one into E to E. I do want to also fix up my namespace so that I make sure that this is right. FizzBuzz controller tests, and change this one also to E to E, right? I'm just doing a lot of refactoring here, proper naming of things, going back and making sure the names of things make sense. Speaking of which, this is not a proper name for my test, so this should be saying should return status code 200 when positive parameter passed. And actually, I'm going to say when single positive parameter passed. So there's my name. Okay, I'm going through and renaming all of my tests. I'm going through and renaming all my code. Hopefully, with all of these moves and changes that I made, nothing is broken. And just to validate that, I'm going to run my tests again. And sure enough, everything is passing. So I can move on now to my next test. And what's my next test? Well, I have a whole slew of these user stories to complete. So my next test is this one right here. So we'll copy that, go to my FizzBuzz get routes. I'm going to close my controller, my FizzBuzz controller methods, and go back here. Okay, so now let's go ahead and add to my FizzBuzz get route test class another fact, the given when then statement, is going to be what I copied from my acceptance criteria. Given the service is running, so I'm just going to copy all of this again. Then I want to say, if I try to submit multiple numbers for parameters, then that should give me a 404. So I'm going to take this exact same line up here, but I'm going to add multiple parameters. So I'm going to say 2 and 3. Now, what this should do is it should return a 404. So I should say result dot status code should be 404. Okay. Now let's try running our tests. And, oh, it passes. Okay, well, let's just rename our test. It's already in green phase, so should return status code 404 when multiple parameters passed. Oh, and I forgot the async, didn't I? Async. Okay, let's make sure my refactor didn't break anything. It shouldn't. Okay, but I do have another refactor that's kind of needed because I'm kind of running into a rule of 3. I've copied and pasted this exact same code 3 times. So what I'm going to do is I'm actually going to move this code into a new function, kind of a setup function. So I'm going to go ahead and define a property on here. Because what this create client is doing is it's returning an HTTP client. So I'm going to go ahead and say private HTTP client. And I'm going to use the nifty syntax here, the expression body member syntax, say a new test server. So that I don't need any of that code anymore. And now I should be able to, oh, and then I need create client. There we go. Okay, so I just took that code that was repetitious and I turned it into an expression-bodied member. This is just a client property that will return essentially the result of creating that client each time. Pretty cool. And then I could just, anytime that I want to create it or use it, then I just need to do that. I could have also done this as a constructor to make it just kind of a one-time thing, but this works for me too. And now I don't need to copy this code or use this code in each one of my tests. I can just delete it because I have the property, the client property now that exists on up here on the class. You could, of course, refactor this a number of different ways, but that's just the one that I chose to do for right now. And it looks a little cleaner, I think. And I'm going to actually just kind of get rid of some of these extra spaces, in fact. Okay. So I think that that's good enough. We're done refactoring. So let's move on to the next one. What's the next user acceptance criteria need to pass? Well, it's this one here. So let's go copy that, create a new test, paste our given when then. I don't need to do the given anymore because that's already taken care of up above. So in my when statement, My when here is going to be that the result from calling on the client, this time it needs to be a negative number for a parameter. So we're going to say API fizzbuzz -1. Now, how you want to handle that may be a little different. Maybe you want to continue to do the same. You want it to be able to do a factor of fizz buzz and, fizz for a -3 and buzz for a -5 if you want to do that, because those are technically multiples. But I think that just in general, the way I want to handle this is that it's an incorrect code or it's an incorrect request. So that's what we're going to return a 400. So I'm going to say result.status code should be 400. Does this test pass? We have a failing test now. Okay, so great. What do we need to do? In order for us to make this work, what's the simplest possible solution? Well, I can go back to my controller and I can make it so that there's some branching logic inside here, but I don't want to just go straight into the controller and start doing that. I have to instead go to my test harness, right? My test class, and add the case for that specific example. So we're going to say another fact here. Var sut new fizzbuzz controller when, so we're going to get a iAction result the -1, right? That's my specific use case here of the -1. Then what should be the result of that? Well, it shouldn't be an okay result. It should actually be there we go. I don't want to say okay result. It's going to be bad request. That's what it should return. Okay, so obviously that new test that I just wrote is going to fail. So we should see failing of 2 tests now, right? 2 failing tests. And by the way, if you like, there are test runners like this one in Visual Studio Code, which I find very handy. And if I run all the tests here, we should see that we get all of, we should get now my end-to-end test is failing, and I also have a failing test here inside of my fizzbuzz controller test fizzbuzz. So if that's something you prefer, you can certainly use that. That's the test that's failing. So how do I make this pass? Well, I need to add some sort of logic, and for now, I'm going to go ahead and continue doing it in the controller, but that's because for now, it's such a simple little silly application. I don't really have any reason to expand on the architecture, not just yet. So I'm just going to go ahead and do an if statement in here. If the number is less than 0, then return bad request. Okay. And let's see if that allows this to now pass. So this test down here should now pass. It does, and in fact, the one above passes. Nice. So we're done, right? That's all that we need to do in order to make our to make the end-to-end test, the acceptance criteria pass. So that means I can go back and refactor all of this. So I'm going to say this is no longer test name async. It should be should return status code 400 when passed negative parameter. And then same thing for my get method here on my controller. This is a little different. It should return bad request result when passed negative value. Or -1. And I think that that should represent or reflect a better test name for each one of these. That looks a lot better. Run each one of the ones that didn't get, make sure that my refactoring doesn't break anything. Yep, okay, we're still passing. Okay, great, so all our tests pass, and we can move on. We've got our refactoring done. Well, so what might I want to consider here when it comes to refactoring? Well, I'm starting to get to the point where the controller is starting to do a bit more than I want it to, right? Because our controller is kind of starting to think about to think about this branching logic, right? And that's not really what it's supposed to be doing. It should be doing more collaboration. The controller should not be in charge of the business rules. So I need to make it so that instead of doing that, I pass this along to some sort of service. And that means that my controller tests that I have up here, these things actually are really acting as unit tests or business rules tests that are really not right. I need to be making it so that this controller is leveraging a service instead. So what I'm going to do is I'm going to add a new test down here that is going to be a collaborator test. I wanted to get to a point in this code, in this walkthrough, that I started to build a collaborator test, and I got to a point where it made sense to start building one. Because the last thing you, again, want is your controller to be in charge of logic like this. Okay, it may have, in terms of the bad result request based upon something a service returns it, determining whether it's going to be a bad request or an okay request. But this kind of thing about determining based upon the number itself, based upon the parameters it's passed, instead of handling that or handing that off to a service to figure out, that's not the kind of logic we want in our controller. And instead, this controller should be a collaborator. It should be handing or figuring out which service to call upon and which service to pass this information to. That's what the controller should be doing instead. So that means back here in my FizzBuzz controller get method test class, I need to write a new test that is going to be a collaborator test. And it's going to be something like this. I need it to utilize some sort of FizzBuzz service. And now I can think about, okay, how do I want my controller to be given this FizzBuzz service? Well, I think constructor injection makes sense. So I'm using this again as a whiteboard. I'm using this FizzBuzz controller underscore get method class, test class, to figure out how I want my application and my architecture to be constructed. So to do this, I'm going to go ahead and define again I'm going to define a mock that's going to be my FizzBuzz service. I haven't created it yet, but I know that eventually I'm going to shovel the logic over to the service that determines what is going to be returned. So I'm going to say on this mock, I'm going to call this FizzBuzz service mock. It's going to be a new mock. This is coming from the MOQ library. And I want to mock up something I'm going to call iFizzBuzz service, which doesn't exist yet. So I need to go create that. I'm going to go ahead and put that in my web API here. So I'm going to add a new folder called services. And in here is where I'm going to make my new C# interface. I'm going to call iFizzBuzz service. And actually I named it wrong. Capital B, there we go. And that should now make this work if I bring in iFizzBuzz service. It should bring in iFizzBuzz. Did I spell it correctly? I thought I did. Maybe I just need to bring in the using statement manually. Using fizzbuzz.webapi services. Well, it should exist. Not sure why it's not happy. Maybe I just need to recompile this. Yeah, that seems to work now. Okay, good. So now we have our iFizzBuzz service. Now I need to continue setting up this mock. I need to make it so that it returns something when it gets the -1, right? So rather than having our controller logic figure out what to do, I want to move that to some sort of service that implements iFizzBuzz service. But for now, I need to mock that up in my collaborator because I don't have a FizzBuzz service. This test suite, or this test class, I should say, is about the FizzBuzz controller. So from the perspective of how my FizzBuzz controller is behaving, I want to make sure that the FizzBuzz controller is calling on the method on my service. That's a collaborator test. I'm testing the collaboration. I'm testing the behavior of my controller, that it is going to, in fact, call on the service to find out the answer, not that it is going to answer the problem itself. So what I need to do then is to go ahead and pass in or set up my mock that if the method on here I'm going to go ahead and call, and I'm designing this. I'm designing the service. I haven't created the service yet, but I already know that the interface on it should have a getAnswer. That's the name of the method I'm going to create on my FizzBuzz service that is going to take in the number and then return something. And what it's going to return, I think, should always be a string. I'm going to go ahead and say one of the things it could return is invalid. And now I need to add this getAnswer method to my interface on the iFizzBuzz service interface. If we go to iFizzBuzz service, we'll now see there's a getAnswer method. The one thing is it's trying to return void. It should be returning string. And also, I think instead of v, it should be something like value. So now my getAnswer method works on my setup because the interface for iFizzBuzz service is set up now with the getAnswer method that takes in a numeric integer parameter. Now I just need to pass into my controller the iFizzBuzz service that I have mocked up. Now this is going to complain for a good reason, because FizzBuzz controller right now doesn't take that as a constructor. Okay, so I'm going to go ahead and generate a constructor in FizzBuzz controller with fields. And if I go take a look at my controller now, I have this object. I don't really like the idea of naming it object, so I'm going to fix that. Okay, now with that in place, what I really want to make sure now is that when the action to call on the get method of my FizzBuzz controller, when that same get method is called with a -1, I want to make sure that what it's doing is not that it is answering the question of what kind of result should it give, but rather that I want to make sure it is actually calling the service. It's doing this call to get answer on the service. That's what I actually want to assert on. So I'm going to go ahead and define the result. Again, it's the same action, -1 on the get method of my controller. But what I want to assert on is that the FizzBuzz service mock, I want to verify that on the service object, the getAnswer method was called with -1. That's what I want to validate. I'm validating that it is in fact exhibiting this behavior, not the answer. Notice we are not checking for invalid. We're not checking to make sure that we're getting an answer of invalid. What we're actually doing is we're verifying that on the service object, the getAnswer method with a -1 was called. And that is, at this point, is going to fail. It should fail. And maybe I should use the test runner up here. And actually, it doesn't like there is no argument given the course that corresponds to required formal parameter of FizzBuzz service. So I've got an error on line 26 and 27 of get method. So yeah, there's right there. It doesn't like this test anymore because FizzBuzz controller is supposed to take in a parameter. This test is no longer actually even important for me to do. But I'm going to make it do it anyway. So I'm just going to go ahead and copy this. I'm going to keep this test for now, but I just need to fix the test so that it is going to continue to work. So FizzBuzz, I'm just going to keep doing this. I could have, instead of doing this action, I could have gone to the FizzBuzz controller and added a constructor that doesn't take in a parameter, but I don't think that would have been the right route. I'm just going to go ahead and make it so my tests, I'm going to refactor them so that they now utilize the FizzBuzz controller correctly and pass in the mock. So let's go ahead and redo all of these tests here again. We now have this test name 1. It is failing. We'll deal with those two in just a moment. But it is currently failing. Expected invocation on the mock at least once, but was never performed. So the getAnswer method was never called. That is, so the controller is not exhibiting this behavior. And of course it's not, because it's receiving the FizzBuzz service, but right now, it's not even invoking the function. So what I want to do then is I want to fix this. I want to go ahead and say, well, okay, what should it be doing? Well, let's go ahead and have it so that if not number equals 0 equals better, if this dot FizzBuzz, actually, I'm just going to say FizzBuzz service dot getAnswer of the number is equal to invalid. Otherwise, return OK result. So now we're making sure that we are invoking the get answer. And actually, I should probably just do -1. Let's see what that solves. By saying get answer -1. Does test yeah, test name now passes, so that works. This one fails though. It should be returning an OK result when I pass in when I get a +1, it should be returning an OK result. So we still have, so the way that I tried to solve this didn't work, of -1, but if I pass in number, let's see how many tests we pass now. Ah, that's a lot better. Okay, these tests are no longer passing though. These end-to-end tests no longer pass. So should return status code 400 when pass negative parameter. What's the problem here? Well, it's unable to resolve service for type iFizzBuzz service while attempting to activate controller's FizzBuzz controller. Aha! This is a new problem. This is a new problem, and we need to make these tests continue to pass. So we've done something in our code, or we need to do something to our code to continue to make these end-to-end tests pass, beyond what we did just to make these tests pass. So what is it that I need to do? Well, the problem is I don't have a service. I'm only mocking it. I don't have an iFizzBuzz service. So when the instance of my application is getting spun up, right? When I'm trying to create an instance of my client here on my test server, well, that startup file currently doesn't have any services that are activated for the iService class, right? We're getting the error here. So when it tries to go and create a unable to resolve service for type iFizzBuzz service. It can't resolve an iFizzBuzz service when it's trying to make an instance of the controller, because in my setup file, there is no service right now configured for iFizzBuzz service. So I've got to go fix that. I got to go create a FizzBuzz service that will return some logic about what I have essentially done here in my FizzBuzz controller, right? This stuff here, this logic that we had here of, or right here, I should say. So get -1 should return invalid. We've got to actually create a service that does that type of logic, right? We're getting to, I can't make any of these tests pass until I actually start implementing a real solution, right? That's what I'm getting at. I've put myself into a corner, but it's not a bad corner. This is exactly the corner I'm supposed to be in. So let's figure out how we're going to solve this. Okay, let's go ahead and create a service that implements the iFizzBuzz service. In order for me to do that, the first thing I need to do is actually write a test. So I'm going to go ahead and go to my tests folder, create a new folder, FizzBuzz service tests. I'm going to make my first, oops. I'm just going to call it foo for now. The first test I need to make is going to be the one that essentially does, or at least solves this problem of implementing iFizzBuzz service. So I'm going to go ahead and say that, and this can be, I could solve that particular problem, but actually what I think I want to do is go back to go back to zombies. I want to make a method. It's going to implement iFizzBuzz service. We already know that, but it needs to handle the Z or 0 case. So I'm going to go and say var system under test is going to be a new instance of this FizzBuzz service. And on the service under system under test, let's go ahead and create that FizzBuzz service now. 222 services here. This is where I need to put it. FizzBuzz service. Okay, so my FizzBuzz service, I know that I want to call on it. There's going to be this getAnswer method. I already know that because I have an interface that I ultimately want it to implement. And I need it to be able to take in the value of 0. And what do I want this to respond to? Or what I want a 0 to be a response of? Well, do I have any other cases right now of 0 that I already know what I want this service to respond to with a 0? And the answer is no, I don't. So I need to determine that now. How do I want this to respond when it gets a 0? Well, I'm going to say the result should be a string. And I want to just say is, do we want 0 to be invalid, or do we want it to actually respond with, let's just say 0. I'm going to leave it at 0. Why is getAnswer no code actions? FizzBuzz service. Oh, because it's returning a void. It should be string. Okay, so now we have our test here. We finally know what 0 is supposed to do. Let's make sure that it passes, which of course it won't. I'm going to have more failing tests. I know with all this red, people get a little like flustered, but that just means we need to solve these one at a time. The method or operation is not implemented. That's the first failing test, right? For this test name. It needs to be implemented. Okay, let's go ahead and implement it. What's it supposed to do? Well, it just needs to return 0. I'm going to also change this to number. Does that solve, is that enough of me, enough work done on this test to make it pass? Yes, it is. Because now we're down to only 2 failing tests and passing 6. So what's the next test that I need to make it pass? Well, let's just take a look back up here in our tests. Unable to resolve service for type. We're still back at that. We're back at the original problem. I now have a test though, or I now have a service that I should be able to implement iFizzBuzz service. So let's go ahead and implement on our FizzBuzz service. iFizzBuzz service. Should be good enough, right? Let's run our tests again. See how many we're failing. Oh, I should still be 2 actually, because I just realized I haven't actually set up my startup class. So let's go ahead and do that. Let's add transient for iFizzBuzz service is going to return an instance of FizzBuzz service. Now let's see what happens when I run my tests. Ooh, we're down to only 1 failing test now. Which one is failing? Status code 400 when past negative parameter. Status code should be 400, but found okay. So when past a negative number. So we need to go to FizzBuzz get route. When past a negative number, it should be returning 400, but it's returning a 200. So why is that happening? Well, let's take a look at our FizzBuzz controller. And it looks like unless we're getting invalid, we're returning okay. So that means we need to, if we're not getting invalid, it seems like that's right. That doesn't, I don't see any reason why that logic should change. What should be changing is whether or not a negative value should return invalid. That's what should really be happening, right? It should be returning a bad request result if invalid is what it gets returned. But right now, our FizzBuzz service is only returning, it doesn't have any logic in it that is returning invalid. So I've got to add a test now to my FizzBuzz service test suite here, FizzBuzz service of foo. Actually, let's rename this. So the name of my test class should be FizzBuzz service underscore get answer method should return zero when past zero. That should work. Okay, now for this one, this new test, I need to make it so that my old test passes, which was that it needs to return invalid when it receives a -1. So we're going to say var sut new FizzBuzz service var result from sut get answer of -1 is that it should the result should be invalid. All right, we have 2 failing tests now from that. Let's see why. Expected result to be invalid with a length of 7, but 0 has a length of 1. Oh, that's right, because we actually need to make this have some sort of branching logic. So we're going to say if number is less than 0, then return invalid. That's going to make that test pass. Oh, in fact, we're passing all our tests. Woohoo! So we used all of those failing tests and knock them out one at a time to figure out where we should be making our changes, right? And what kind of changes did we need to make? And that's the whole thing about outside-in testing. It's a different process. We're still using tests first. We're still using those tests to make our decisions for us. Or I should say, to help us decide where to go with our decision making and to plan out the architecture of our application. I'm going to change my test name here because this is probably invalid. This should say, well, now this time, so this is our FizzBuzz controller get method. What should it do? Well, it should call get answer method on FizzBuzz service and that's actually all I really need to do. I'm just testing behavior. I could also say should call get answer method with negative or with parameter, same parameter. That was passed. Okay, and that's maybe a bit more specific. Let's rerun all of our tests here. I do want to rediscover just to make sure I get all of my test coverage here. Yep, see there's a test that I forgot to rename, so that's a good one to fix here. So this is our FizzBuzz getAnswer method. So we're going to say should return invalid when past -1. Okay, so we can see that we're starting to build out our application, and we're doing it in an outside-in fashion. But what we know now, what's the really terrific about this, and I'm going to wrap it up here. I'm going to wrap this really long video up with just kind of this thought. We've gone from this set of criteria that we outlined in our user stories via the acceptance criteria. We've used this one at a time, each new acceptance criteria as the definition for our classes, or I should say for our tests in our end-to-end tests up here. And once these tests are passing, then we know that our user stories are going to be complete. So once we have this last one in place with a non-number, and we have that returning an invalid, and maybe we can do that. Maybe I guess I'll make this video one little bit longer, a little tiny bit longer here, is I'll do this one last test here, and then I'll let you complete the rest of these on this code. So we'll go ahead and copy this. I do think I have a file name somewhere named foo. Is that right? I think I still had a file name named foo somewhere. Yeah, I do. I need to fix that up real quick. I'm still kind of in my refactor phase before I write my next test. So I'm good to do that here. Okay. So let's take that last acceptance criteria. We'll do one more time. Go to our end-to-end tests here. Our FizzBuzz get route. We'll paste that end-to-end test here. And just see if you can follow along with what I'm going to do. Okay? I'm going to try to maybe not explain it as fully and just do the work here and see if you can follow along. Okay, looks like I didn't even need to do anything, right? I didn't even need to do anything in terms of logic. This is already a passing test. And I can prove that if I try to do like 300 or something, so I can see the error. Just make sure that that test does have a reason to fail. If it is ran and things don't match, yep, so it fails if that happens. So since this is passing, I just need to refactor now. I'm going to go ahead and say should return status code. Here, I'll just copy all this. And actually, I forgot the async. I do that from time to time. Return status code when passed non-number. Okay. Should be able to run all my tests. I'll run those there, and then also I like to go up here. It depends on where you want to go. I like to run the commands, but if you like these test runners because they just make more sense to you, and it does obviously make it nice because I can see all the names of all of my tests that way. Oops. I can see all the names of my tests that way. That way I know if I've missed any and I forgot to rename them. The one thing that you will notice, though, and I'm going to kind of wrap this up, and the outside in process, you'll notice that we're not really following some of the things that might be the more conventional wisdom around tests. And that is, if you look at my test, which one has the most? Where do you see on the testing pyramid, if you will, what's being tested the most? Well, the most tests exist inside of the get route request. So it's kind of my end-to-end tests that have the majority. But the reality is I have fewer overall tests than if I was to do a full suite of unit tests, right? If I was to try to do all the complexity of all of the low-level business rules up front, there would be a lot more of the tests that are passing this service for the get answer method, right? There would be a ton more of these going on. And if I'm doing inside out TDD, that's what you would expect. But with outside in TDD, I'm actually letting what the user expectation should be is driving the majority of my test requirements. But that is a way for me to know that my integration is working properly and that I'm getting exactly the behavior out of my application that I should. So it's a very different set of results of how much my tests are going to how many tests I'm going to have. And you may be also thinking, well, I'm not going to have good enough code coverage this way. I'm not going to have good enough test coverage this way. But that's simply not the case. I simply haven't gone far enough into this where I need any more code than I've already written, right? It's adding more acceptance criteria or completing more of the acceptance criteria pieces that is going to ultimately lead to an implementation that actually matches all of this acceptance criteria. And I've eliminated a lot of waste in my code. My actual production code here is actually quite small. I have a controller and I have a service. And these are essentially the same services and controllers that I would be building if I was doing it inside out. It's just that I don't need all that much logic yet in any of this because I haven't gone through enough of the acceptance criteria of my user stories to make it so that that additional bit of logic is necessary yet. So I've actually eliminated a lot of waste. I don't have a full-fledged implementation with a bunch of different branching logic to it, with all sorts of scattered architecture everywhere. I have a very bare bones implementation because so far that is all that my user stories and acceptance criteria has asked for. Now, once I start digging into this, and once you start digging into the more specific scenarios of FizzBuzz, then you're going to see your implementation start to fill out a little bit, but you will know and you'll be confident that you are only adding as much code to your code base as is necessary to meet the requirements of what your user says they need. So that is what is really a key part of this outside-in philosophy, is that we are only going to do enough of the code that is necessary to make what the user says they need actually happen in the system. And I don't have an excessive amount of tests that go above and beyond to exercise every tiny way that the code could possibly behave, and therefore I also need to implement in my code, because that's not our user requirement right now. I've eliminated all of that wasteful extra thinking. There's a lot of windy, twisty ways, and you have to think carefully about how am I going to make these tests pass, and there's a lot of red on the screen, and you have multiple tests that are failing at once, and those things can seem very scary to somebody doing an outside-in TDD path. And that quite often drives people away from this methodology, this way of going through things. But the benefit of this is really in the solution. The solution is very small. It doesn't have a bunch of extra weight. There's nothing that I did in here that was extra code that I will not use later on. Even the tests that I had for my controller that I have up here, right, where we're checking to make sure that the bad request result is what's being returned. None of those tests did I really have to do much to, other than, you know, and I probably could have just actually deleted these. I could have deleted these 2 tests and actually slimmed it down. And in fact, I think I will. I don't see any reason why I need to have those, because that bad request result is essentially the same thing that's being tested in my end-to-end test. So this is kind of a duplicate test going on here. So I'm actually going to go ahead and delete these, because I think that that's duplicate code, and that's perfectly fine. I can do this, and I'm mocking these things out so that they're pretty fast tests if I decided to leave them in. But now the only thing that actually matters here is the collaborator test that I wrote for the get method that just simply says, hey, make sure that the behavior of this method is that it actually returns back, or that it goes and calls that get answer method on the service instead of trying to do the logic itself. And once that's in place, I don't have any reason to do those other tests. I can go ahead and remove them, because I had essentially duplicate tests running, right? I had the duplicate test going on there, where I was doing some sort of integration test or logic branching testing going on inside of my FizzBuzz get method class. And that just didn't make any sense for me to be doing. But yeah, so now we actually have, look at how few tests we actually have on the code base. It's only 3, whereas we have basically almost double that amount in terms of end-to-end tests. But what we have is an integration test in the form of end-to-end tests that are testing the whole functionality of the application and making sure it matches the expectations of the client. And there's not really all that much that I need in terms of testing for the pieces like the FizzBuzz service or the FizzBuzz controller. None of that is really all that important, because we know that our end-to-end tests are passing. It's a very different way of thinking. It's a very different train of thought that you have to follow. And maybe there were some points that I kind of ran into and didn't explain fully as well as you would like me to have. If there are some of those places where you're saying, Steve, you didn't quite answer this, or I didn't quite understand why you made this decision, please feel free to drop me a comment in the comment section below this video, and I will be happy to answer that question. But hopefully this is shown you. This may not have been the most perfect demo. It's still a little early in the demo phase, so I've got some kinks I need to work out in it. But I hope that it has laid down the foundation for you to feel comfortable enough in maybe trying to experiment with it on your own, in your own code base, and to start to feel a little bit more comfortable with this idea of doing outside in TDD instead of always doing the inside out style. So thank you so much, everybody, for watching, and I hope you had a wonderful time learning more about this. At this point, I really just want you to take the rest of these pieces of acceptance criteria and scenarios and implementing them in your own version of this application. That would be the activity I suggest that you do at this point. So thanks everybody for watching. I hope you had a great time, and I look forward to seeing you again in the next video.